Alright, this is our last lesson of the year, and it's on a really big and important topic called linear quadratic systems. Alright, a lot of times this question is the last question on the Regents exam, which is worth the most points. Okay, not all the time, but many of the times, at least half of the times that the exam has been given, the last question has been on linear quadratic systems. The other half of the times it's usually on a proof, which we'll be doing those during the review again. So put the heading that I have up there, alright, skip a line, and write down the title of the lesson. It's linear quadratic systems. Okay? And so this is going to be LQ for linear quadratic, and it's going to be dash lesson 1. There's only going to be one lesson. So skip a line and let's write down our first important piece of information. In a linear equation, which remember is a line, right? None of the variables are raised to any power higher than 1. Okay, so you're not going to see any squareds or cubes or anything like that. All right, you'll see x's and y's, or just an x and just a y. All right, and remember, this is the equation of a line. Skip a line, and here's our next piece of important information. The graph of a linear equation is a line, and the slope-intercept form for the equation of a line is y equals mx plus b. Okay, remember that y equals mx plus b is the slope-intercept form for the equation of a line. Skip a line, let's put our next piece of information down. A quadratic equation, which is either going to be a parabola or a circle, okay, has one or more of the variables squared. Remember, that means raised to the power of 2. But none of the variables are raised to any power higher than 2. Okay? So at least one of the variables has to be raised to a power of 2. Could be more than one, but at least one. When only one of the variables is squared, the graph of the quadratic equation is a parabola. Alright? And we'll see what that looks like in case you don't know, but really at this point you should know a parabola is one of those U's, right? It's a U or it's a hill. Okay? So let me just really quickly give you a quick example of what that looks like, right? For a parabola, what you have is either this or this. Okay? The general form for this type of a quadratic equation is y equals ax squared plus bx plus c. Okay? Next. When two of the variables are squared, the graph of the quadratic equation is a circle. Alright, and we've graphed circles before. We did that in a topic this year. And if you forgot how to do that, you better go back and review it. Okay? So remember, the center radius form for the equation of a circle is x minus h squared plus y minus k squared equals r squared, where h comma k is the center of the circle and r is the radius, which can simplify to x squared plus y squared equals r squared when the center of the circle is the origin. So in other words, this is the equation that we're using, this big long one. But if the center is 0, 0, that means h and k are zeros. So sometimes this equation can simplify to x squared plus y squared equals r squared. But that's only if h and k are 0. A linear quadratic system, then, is when you have two equations. Okay? One of them is going to be a linear equation, and one of them is going to be a quadratic equation. That's all a linear quadratic system is. One linear equation and one quadratic equation. So when we graph a linear quadratic system on the same graph, three situations are possible. Okay? the first situation is that the line intersects the parabola or the circle twice. Okay? So in other words, it could be like this, right? Or you could have a circle and it could be like this. Okay? That's the first option. The second option is the line intersects the parabola or circle once. So that would be something like, say you had a parabola and a line just touching it at one point, right? Or if, say, you had a circle and you had a line just touching the circle at one point. Okay? And then our third option is that the line does not intersect the parabola or the circle at all. So you could have a parabola and you could have a line underneath the parabola. Or you could have a circle and you can have a line not touching the circle. Okay? So those are the three scenarios that you're going to see when you do this. All right? Each time the line will intersect the quadratic equation, it's a solution. So in this case, there's two solutions, right? In this case, there's only one solution, and in this case, over here, there's no solutions. Okay? So the solutions is where they intersect. And finally, you must be able to solve a linear quadratic system graphically, that means on graph paper, and using the calculator. Okay? So we have to be able to do it both ways. And I'm going to show you many, many examples. All right? So, on the next sheet, we're going to follow the procedure. So again, make sure every new sheet you start with the heading, right? So now here's the procedure for solving these systems of linear quadratic equations, or linear quadratic systems. Step 1 is decide if the quadratic equation is a parabola. Remember, that's when one variable is squared, or a circle, and that's when two of the variables are squared. So if it's a parabola, we'll go to step 2. If it's a circle, we go to step 6. So let's assume it was a parabola, we'll go to step 2. Rearrange the quadratic equation so it is in standard form. And for a parabola, when we're talking about the standard form, it's going to be like y equals ax squared plus bx plus c. Okay? So for example, it could be like y equals 2x squared minus 3x plus 2. All right? That would be standard form. You want the x squared term first, the x term second, and then the term without the x last. Okay? Next, find the axis of symmetry using the formula x equals negative b over 2a. You have to memorize that formula. It's extremely important. You can't do this problem without it. This is the equation of the line of symmetry of the parabola, and also gives you the x-coordinate for the middle of the chart you will create to find the other points you will use to graph the parabola. So here's what that means. What the axis of symmetry is, right? Because remember, a parabola is symmetric, right? On one side, it's the same as the other. It's got like a mirror line right here, right? That line is the axis of symmetry. Okay? And it's going to be x equals something. And to find out, because remember, x equals some number is a vertical line. So to find that where that vertical line is on our graph, we solve this formula, x equals negative b over 2a. Okay, and we're going to do that so many times that you'll get plenty of practice with it. So just know that we're going to have to do that now. Create a chart of x and y values. Start with the x value from step 3, that's the last step, in the middle of the chart, and pick 3 x values above it and 3 below it. Plug each x value into the quadratic equation and solve for its corresponding y value. plot the xy pairs on a graph and sketch the parabola. Okay, and that's it for the first parabola part. Now, if we came to step 1 and we figured that it was a circle because it had 2 variables squared, then we would go to step 6, which is going to take us through a similar process, right? First, we would rearrange the quadratic equation so it is in center radius form because it's a circle, right? Then we would graph the circle using the center, h comma k, and the radius r. Okay, so after you then what has happened by the end of step 7, you've either graphed the parabola or you've graphed the circle. And then we're going to graph the linear equation, so we go to step 8. Rearrange the linear equation so that it is in slope-intercept form, y equals mx plus b. Graph the line using the slope and the y-intercept. Okay? If graphing a line is something you still have trouble with, well, you better come to extra help. Okay? Note, remember that an equation of a line like y equals 3 is a horizontal line, that means going left to right, that goes through the value of 3 on the y-axis. Okay? And an equation of a line like x equals 2 is a vertical line, remember that's up and down, that goes through the value of 2 on the x-axis. Okay? And we're almost done now. If the linear equation and quadratic equation intersect, circle where they intersect, write down the coordinates, and write down the quadrants that it or they are located in. That means where they intersect. So here's what I mean. First of all, you have to know what the quadrants are, right? So when you have a graph, okay, and this is the y-axis and this is the x-axis, this is quadrant 1, this is quadrant 2. So what's happening is it starts in the upper right and it goes counterclockwise. So 1, 2, this is quadrant 3, and this is quadrant 4. Okay? Because sometimes the question will ask you, what quadrant is the solution in? So if you have a parabola like this, right, and we had a line that went like this, right, the solution would be here and here. So the solution would be in quadrant 1 and 3. Okay? Because a lot of times there's multiple choice questions on this where they're asking you what quadrant is the solution in, or are the solutions in. Okay? So, finally, we're going to check your answers by plugging each one into both equations and by using the graphing calculator. This is a reminder. Write it down. You must be able to solve a linear quadratic system graphically, that means on graph paper, and using the calculator. So every time I solve one of these problems with the calculator, you have to do it too, because if you don't practice doing it, you're never going to remember it for the Regents. I promise you that. You need to, every single time I use the calculator, you need to use it also. Alright? So, you probably have 2 pages front and back of notes right now. So on the first page, let's put 1 out of 2, and on the second page, put 2 out of 2. Okay? Now we're going to start the problems. Alright. I'm going to zoom out a little bit. Try to zoom out. There we go. Okay. Don't want to zoom out too much so that you can't see what I'm writing. Alright. So, put my pencil out here. Okay. So, the first problem. Let's put a number 1 here. Okay? I'm actually going to zoom in a little bit. I want to make sure you can see this. Okay. Number 1. And they usually start the same. It's going to say solve the following system of equations graphically. And for this problem, the two equations are y equals x minus 2 and y equals x squared minus 4x minus 2. Okay? So, first thing we do is we want to draw our graph. Okay? So what I'm going to do is I'm going to put a horizontal, I'm going to skip a line and put a horizontal line going underneath our problem. Alright, we're going to leave that space for just our problem. Okay? And we're also, now we want to find the center, right, to draw our axis. So this is 8.5 inches wide, right? So 4 1/4 would be the middle. That's right here. So we'll go to the closest line to that. So right there. And that's where the top of our arrow goes. Okay? And so we draw a line all the way down from there right down to the last box before the edge of the paper, just like that. Okay? This is our Y. Okay? Now we need to find our X. So I went from this line to the 9, right? Because that's where this lines up, the tip of that arrow. So from 0 to 9, halfway between that is 4 1/2. So at 4 1/2, I'm right here. Okay, so that's where my x-axis will be. Okay, and now I just have to label my x-axis. Okay, so let's see how we're going to do this now. We're going to follow those steps. First we have to look at our equation, and I'm going to look at the quadratic equation first. Right, that's the one that has a squared term in it, the bottom one. I notice that it only has one variable squared. So this is a parabola, and what I do is I now write that next to it just so I don't forget. And the top one then must be the line. Okay? And you know that because it doesn't have anything squared up here. So that's the line, and this is a parabola because it only has one variable squared. Now, after that, I have to rearrange this this parabola to get into y equals the ax squared plus bx plus c form, right? That's step 2, rearrange it so that it's in that form, but it already is. See, the x squared term is first, the x term is second, and the term without the x is last, and that's what we want. Okay? So I go to my next step. And the next step says find the axis of symmetry. So that's what I'm going to do next. And I'll do it right up here. Okay, we have x equals negative b over 2a. So that equals, now b is the number next to the x, right? Because it's ax squared plus bx. See, b is what's in front of the x. So in this problem, what's in front of the x is a negative 4, right? So b is negative 4, and I'm going to put that in parentheses because this equation says negative b. So it's negative 4. Okay, you can see where a lot of kids would make would make mistakes right off the bat. Okay, they mess that up. All right, this is negative b, and my b is negative 4, so it's negative 4 over 2 times a. Look at my equation here. A is what's in front of the x squared. So there's a 1 in front of this x squared, right? So this is 2 times 1. So when I simplify this, a negative 4 is a positive 4, and 2 times 1 is 2, so what I end up getting is just 2. Okay? So I know that my line of symmetry, I mean my axis, or my, really it's a line of symmetry, but my axis, so my axis of symmetry is x equals 2. Okay, so let's draw that in, and we draw that line dotted. Now, we do want to just put a 1 here to show that we're going by ones, and we'll put a negative 1 here, and a 1 here, and a negative 1 here. That shows that we're going by ones in each direction. Okay, we only have to put the 1 there. Once we put a 1, then everyone can assume that we're going by ones. So you don't have to go all the way up to 10 or 20 or anything like that. So now at 2, we want to draw in our axis of symmetry. Now remember, x equals is a vertical line going through 2 on the x-axis. So it goes through, here's 2 on the x-axis, right? It's a vertical line that goes through 2 on the x-axis, and you make that dashed. Okay? Okay? So, there is my axis of symmetry. Now you have to label that axis of symmetry, and it's x equals 2. Okay? So my parabola is going to either come up, and as soon as it hits this axis of symmetry, it's going to go back down, or it's going to start up and come down, and as soon as it hits this axis of symmetry, it's going to go back up. Okay, this is where the turning point of my parabola is going to hit. All right, it's going to be reflected over this line. So that's what I did in step 3. So now 4, create a chart of x and y values. Start with the x value from step 3 in the middle of the chart and pick 3 x values above it and 3 below it. Okay? So here's what you do. In the bottom, in the third quadrant, right? Let's label our quadrants also. Go up from this arrow and come right from the top arrow, and where they meet, put a Roman numeral 1, that's quadrant 1. And then up here, this is Roman numeral 2, quadrant 2. Down here, Roman numeral 3 for quadrant 3. And over here, Roman numeral 4 for quadrant 4. Okay? So, maybe we should do this on the back. I think we'll do it on this side. So, we want to draw a chart. Alright, so I'm going to go one box over here. This is going to be the bottom corner of my chart. And our chart should be 8 high. So 1, 2, 3, 4, 5, 6, 7, 8 high. And it should be, let's see, 1, 2, 3, 4, 5, 6 wide. 1, 2, 3, 4, 5, 6 wide. Okay? And let's box that out. Now in the first column is our x values. And in the last, let me think here. X values. Actually, we only really need 2 columns. Okay. You only need 2 columns because we're going to use the calculator to help us here. So you only need 2 columns, but you still do need 8 rows. Okay, so draw in your 2 columns and 8 rows. Let's underline. We can leave it like that actually. Okay, now look what it says. Start with the x value from step 3. That's what we got for the axis. That's what we got for the axis of symmetry. So we want to start that as the middle of our chart. And then we're going to pick 3 points above it and 3 points below it. Okay? So, if you look, there's 1, 2, 3, 4, 5, 6, 7 places left. So in the 4th spot, we're going to leave 3 above and 3 below. So right in the middle now, we're going to put that axis of symmetry value that we got for x. And we got 2, right? See, we got 2. So we put that right in the middle of our chart. And now we're going to pick 3 values above it. So let's do 3, 4, 5, and 3 values below it. So let's do 1, 0, -1. And you go in order just like that. Okay? Now, we should separate our x and y column so we don't get too confused here. And we should also just clean up our chart a little bit. Let's put those horizontal lines in there. Keep everything clear so we don't lose any points for anything. Okay. So, what you need to do now is find the corresponding y value. So we just take each one of these values for x and we plug them in to our quadratic equation here, the x squared minus 4x minus 2. Okay? So first we're going to take 5. Right? And we always put it in parentheses when we do this. So 5 squared minus 4 times 5, right? Minus 4x minus 2. And we get 3. So that's our y value, 3. Now we take 4 and we do the same thing. 4 squared, right? Minus 4 times 4. So minus 4 and then 4 in parentheses and then minus 2. And we get negative 2. Then I do the same thing here for my 3. 3 squared minus 4 times 3 minus 2. And I get a negative 5. Then I use my value of 2. So I have 2 squared minus 4 times 2 minus 2, negative 6. Then I use my 1. So 1 squared minus 4 times 1 minus 2 is negative 5. I do the same thing for my 0. Negative 2. And then I do the same thing for my negative 1. So I'm putting it in the parentheses. Minus 4 times negative 1. Make sure you use the negative button, right, for when you're putting in negative 1. So minus 2. 3. Okay? Now, also you want to put an arrow next to your axis of symmetry value. Okay? That was our middle value. Now look at our chart. Alright, you should notice something about the y values. Right? They're symmetric about our axis of symmetry. Right? In the middle here we have negative 6. Then look above and below it. Negative 5, negative 5, negative 2, negative 2, 3, 3. That is always going to happen. And if that didn't happen, that means you made a mistake when you plugged it into the calculator, or you made some other kind of a mistake. Alright? It'll always be symmetric about that value. That's why it's called the axis of symmetry. This 2 comma negative 6, that's the turning point. So let's plot that value first. Alright? 2 comma negative 6. 2, and it's going to be on our axis of symmetry. So 2 comma negative 1, 2, 3, 4, 5, right here. Right? That is our turning point. So now let's graph the next points. 3 comma negative 5, I'm going to pick one above it. So 3, 1, 2, 3, comma negative 1, 2, 3, 4, 5. So that's right here. Now let's go below it. 1, negative 5. 1, negative 5. You see how it's going to be symmetric about this line? They're going to be on the same distance from the line. Right? So now if I plot 0 comma negative 2 and I plot 4 negative 2, see, they're the same distance from the line. And now we can plot 5, 3 and negative 1, 3. Okay? And you can see what you have is that U shape. Okay? Sometimes it's a hill going this way, and sometimes it's a U. But notice that it's symmetrical about that axis of symmetry, right? We could fold this paper on that axis of symmetry, and those points would lie right on top of each other. Okay? So not only is it symmetrical in our graph, but it's also symmetrical in our table. And that's why we use that axis of symmetry value as the middle of our table. All right? Because it's right where the turning point is for the parabola. So now, this should look like we want to finish plotting this. Okay, so what we do is, as best we can, a line comes down, and this line should be slightly curved, right? This is not a straight line. There's got to be some kind of a curve, some sort of a curve to it. So I kind of draw a light line at first, and I try to give myself a little help here trying to get that curve in. I make the line nice and thick, and then I'll like darken in where I think it should go later on. So this comes down, and it's a little curve. It's always curved, right? There's no straight pieces to this line. It's always got a slight curve to it. Okay? And what'll happen is this will go up, like this. Now that I have my basic curve, I mean, it doesn't have to be perfect, okay? But now that I have my basic part of my curve down, I'll just kind of darken in where I think the best part of my curve was. And now I just have to finish this side off. Okay? And there's my parabola. I always try to extend my graph to the end of the graph, okay, in whatever direction it goes in. Now, what do I want to do now? Let's look at our directions. So we just finished 5. We sketched a parabola. Now 6 and 7 we don't do, because that's for when it's a circle, and ours was a parabola, so we go to 8. Rearrange the linear equation so that it is in slope-intercept form, or y equals mx plus b. If you look, our linear equation is already in slope-intercept form. It's y equals mx plus b, right? The y-intercept is -2, so I'm going to put -2, which is already a point on my parabola, so I already know one point of intersection is right here. Right, that's my y-intercept. And now my slope is 1. Right, that's what's in front of the x, a 1. So from this point, -2, it's a positive 1 slope. So I go up 1 and over 1. Okay? And all I really need is 2 points to graph a line. Now I can keep going up 1 and over 1, and it'll help me to graph my line. It'll help me straighten the ruler out, right? But all you ever need to plot a line is 2 points. But I like to extend it a little bit just to help me line up my ruler, and then you can go down 1 and to the left 1 in the opposite direction, right? So now let me get out my ruler. See, it helps you line up the ruler. Now, we have our lines drawn. Okay, don't forget to put the equation on your graph. So this is y equals x squared minus 4x minus 2, and this line was y equals x minus 2. Okay? Now, we're almost done. We're on step 10. If the linear equation and quadratic equation intersect, which they do, right? Circle where they intersect. So first I'm going to circle where they intersect. Write down the coordinates. So I'll write down over here, or actually I'll put it right over here. The first one is at 0, -2, and the second one, so just find a blank area, alright, and put it nice and big, the coordinates of those points. So this was 0, -2, and 1, 2, 3, 4, 5, 1, 2, 3, and 5, 3. Okay? And then what else? And write down the quadrants that they are located in. So 0, negative 2, that's not in a quadrant, right? That's on an axis. So let's write down on y-axis, right? And then for this point, it's in quadrant 1. So we could put quadrant 1, just like that. So remember, if a point is on the axis, you just put down what axis it's on. Okay? If it's at the origin, just put at the origin. Alright? And now check your answers by plugging each one into both equations and by using the graphing calculator. Okay? So here's what we do for the check. First we use the equation, what do we want to do first? Let's check, alright, let's use the equation, let's underline check, and use the equation y equals, because we have to check it in both, x squared minus 4x minus 2, right? So let's check the point 0, negative 2. So right now we're checking 0, negative 2. Okay? So negative 2 was our y, so negative 2 equals, and x is our 0. 0 squared, put the 0 in parentheses, minus 4 times 0, minus 2. So that means that negative 2 equals 0 squared is 0. 0 minus 4 times 0 is 0, so 0 minus 0 is 0, and 0 minus 2 is negative 2. So that checks. Alright, now let's also check it in the other equation. Y equals x minus 2. And we're checking again 0, negative 2. So negative 2 equals 0 minus 2. Negative 2 equals negative 2. That checks. Now let's check the other point. 5, 3. Y equals x squared minus 4x minus 2. 3 equals 5 squared minus 4 times 5 minus 2. 3 equals, 5 squared is 25, minus 4 times 5 is 20, so 25 minus 20 is 5, and 5 minus 2 is 3. That checks. And now we're checking the same point in y equals x minus 2. 3 equals 5 minus 2, 3 equals 3. Alright? And I like to make this nice and clear and separate it, okay, because you don't want to make anything sloppy for somebody who's going to be grading your work. Okay, you want to make it as neat as you can, because if they can't read something, or if something is not clear to them, they're going to take off points. I can promise you that. So this is the way I like to box off my check. Alright. Oh, I put that extra line there. Didn't really need that. Okay. So, that is how you solve a linear quadratic system. Okay? It's a long process, and it's going to take a lot of practice, but this is what you got to do. Now, we have to be able to do this on the graphing calculator, so I need you to follow through with this. Okay? They're already in standard form, right? We didn't have to rearrange the equations at all. So I'm going to do y equals, I'm going to clear everything out of there. First I'm going to put the first equation, x minus 2. And I'm going to hit down arrow. And I'm going to put in the second equation, x squared minus 4x minus 2. And now I'm going to hit zoom, and I want it to be square, so z square. Okay, and you can see that is what it looks like, right? Now, if I want to check my table of values, all right, that's the next thing you got to know how to do. So what you do is, you see there's the word table up here, and it's in yellow, so I hit the second button and then I hit graph, which will take me to table. So second graph takes me to the table. Now let's find our axis of symmetry point, which was where x was 2. So here's where x was 2, right? Now y1, remember y1 was our line, right? So that's not the value that's in our table. The value in our table is our parabola, our y2. See, if I go back to y equals, see, our y2 was our parabola and our y1 was our line. So I'm looking at the values in the y2 column. Okay? So again, second table. Now, in y2 I have negative 6, right? That's what I have in my table. And then for 3, I have negative 5. And for 4, I have negative 2. And for 5, I have 3. And when I go the other way, for 1 I have negative 5, for 0 I have negative 2, and if I go up one more, go to the x's and go up, for negative 1 I have 3. Okay? So you can see that everything that you wrote down here was correct. Look, it's exactly written here. Also notice that our answers, right? Our answers are where we have the same y value. So we had, when x was 0, right? Look at our y values. They're both negative 2. That's why 0 comma negative 2 was an answer. And now look where x is 5. The y values are both 3. See that? That's why our other answer was 5 comma 3. Okay? Now you also have to know how to check it another way. You have to know how to go to the graph again, so just hit graph. Now I want to know where these two graphs intersect, okay, without plotting it on a graph paper like I did. So here's what I do. I want to go to calculate. Okay, you see that C-A-L-C word? I want to go to that, and it's in yellow again. So hit second trace to get to calculate. And I want to calculate the intersection, right? So go down to intersect and hit enter. Now, look at your screen. You have a little blinking cursor there, right? And I can move that around by hitting the right and the left arrows. You see how it's moving along the line? Right? You see that? What it wants me to do, look what it's asking me. It's saying first curve. So I'm on the line right now. I want to put that blinking cursor close to that point of intersection on the line. So I want to keep going to the left until it's close to that point of intersection. Doesn't have to be exact. It's never going to be exact. Just put it close. It just wants you to put it close to it. So then hit enter. Now look what it says. Second curve, right? So now that little blinking thing is on the parabola. It's not on the line anymore, right? See how it's going all the way around the parabola? If I keep going to the right, and then I can keep going back to the left. Now it wants me to put that blinking cursor near that same intersection point, okay, on the parabola this time though. So now I can keep going to the left until that blinking cursor is really close to where the line and the parabola meet over here. So I'm going to keep going right about there. Okay, and I hit enter. Now it says, alright, you gave me two values, one from each graph that were close to where they intersect. Do you want me to make a guess as to where they intersect? And I say, yes, I want you to make a guess. And to say yes, I push enter. I say, yes, go ahead and make a guess. So push enter. So it's guessing that that intersection value is at 0, -2. And look what we got, 0, -2. Now we have to check the other one, right? So second, calculate, go down to intersect, hit enter. Now put the cursor near the other point of intersection and hit enter. And do the same thing and hit enter again, and then let it guess again. 5, 3, and look what we got, 5, 3. Okay, so that is how you solve the problem using the graphing calculator. Now you have to know how to do it on the graphing calculator. Okay, you must know how to do it on the graphing calculator, because some problems, you see how this worked out to nice whole numbers and everything worked out so nicely? Well, it doesn't always work out that way. All right? And when these problems don't work out to nice numbers like this, you can't do it any other way except for on the graphing calculator. It would take you 3 hours to do this one problem if it doesn't work out properly. Okay? So you have to know how to do it on the calculator for certain cases. Now, if it tells you on the Regents that you have to do it on the graph paper, graphically, then you have to do it on the graph paper, okay? And it's going to work out to nice numbers like this. There might be like a half, or a quarter, or 3/4, but it won't be like 0.2673. All right. But a multiple choice question on this type of a problem could be a really ugly problem that they're expecting you to do on the calculator. On the calculator, it could take you 10 seconds, and if you tried to do it by hand, it could take you an hour. So you have to know how to do both, and you have to know how to check what you got on the calculator so that you know you did it right. All right? And when you get good, you remember when we plugged all those values in? Before we were plugging in all these x values to get our y values. Well, when you get good at this, you can just put in your quadratic equation, right? I'll just leave it in y2, and I can just go to my table, right? And I know it's got to be symmetric, right? So I just look for where it's symmetric, and I can see right here, it's 3, 3, -2, -2, -5, -5, -6. So I can just write that down right there. All right? But that's when you get good at using the calculator, because you can make a lot of mistakes doing that also. All right? So, that is the end of problem 1. All right, now for problem 2, I'm going to do this a little differently, all right, because I don't really like the way we laid this one out. I mean, you can do it like this. I'm not going to solve the problem any differently. I'm just going to lay it out a little differently so that we have a little bit more room to work with here. So, on the back, okay, here's what I'm going to do. I want you to find the halfway point on the back, right? So since this paper is 11 inches long, the halfway point would be at 5.5, right here. So I'm going to go to the nearest vertical line next to 5.5, which is this one. I'll make a little mark there. And what I want you to do is draw a vertical line straight up and down through that point. So we're going to divide our paper into two parts here. Okay, let me just sharpen my pencil. Alright, now, so on the left side I'm going to do all of our written work, like our table, and if we have to simplify anything and all that stuff. And on the right side we'll do our graph. Alright, we'll keep it separate like that. So on the right side, let's put in our graph here. Now this is basically 5.5 inches, right? So let's see, at 2 3/4 is halfway. So I'm going to go to the closest vertical, okay, and that's where my arrow is going to go. And I'm going to just draw a vertical line down from that to almost the bottom, right? Okay, that's going to be my y-axis. And then remember, this page is 8.5 inches wide, right? So half of 8.5 is 4 1/4. And I go to the nearest vertical, which is this one. And I put my x-axis here. And let me see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that should work. And go 1 before this line, so we don't want to hit that line. So hopefully all of our graphs will fit. It goes to 10 in each direction here, and it goes to even more, like probably 15 in these directions. So it should fit everything we need. Usually a 10 by 10 by 10 by 10 would fit. Alright, so anyway, there's our graph. Now we'll do all our graphing on this side, and we'll do all our other work on this side. So number 2 is solve the following system of equations graphically. And they gave us two equations. The first one is 4y equals 3x. And the second one is x squared plus y squared equals 25. Right? Now, my first thing is to work with the quadratic and identify whether it's going to be a parabola or a circle. And right away I should be able to see that this is going to be a circle, because I have two variables that are squared. Alright? So I know it's going to be a circle. Now, if you remember, right, let's look at our notes. Let's see, we need the other page, the first page of our notes, right here. Here's the equation of a circle. X minus h squared plus y minus k squared equals r squared. But when the center of the circle is at the origin, right, at 0, 0, that means h and k are 0 and 0. So if I plugged in a 0 for h and a 0 for k, and I simplified this, I would get x squared plus y squared equals r squared. And look what I have here. Right? I have x squared plus y squared equals 25. So, since I have x squared plus y squared, I know my center is 0, 0. Right? Now my r squared equals 25. So to find my radius, I just take the square root of both sides. Right? And so r equals the square root of 25, which is 5. Okay? So my center is at 0, 0. Here's my center. And my radius is at 5. 1, 2, 3, 4, 5. So what I'm going to do is take actually a compass. Okay? So if my radius is 5, I know it goes to the right 5, to the left 1, 2, 3, 4, 5, up 5, 1, 2, 3, 4, 5, and down 5, 1, 2, 3, 4, 5. And I'm going to actually use my compass. I'm going to put my compass point at the center. And I'm going to slide this thing until that opening is right over that circle, the distance of my radius, so right about there. And now I'll make a nice circle. And now you don't have to use this, you can do it by hand, but if you do it by hand it's going to come out looking terrible. Okay? You can do that. I recommend using the compass because then you get a nice circle. Now look at this. You see how that line went a little bit past there? So when that happens, you just kind of erase this part of the circle a little bit and make it a little thinner, because it has to cross that point. Okay? So you just kind of fix it up a little bit like that. You don't leave it like that, okay? It must be a radius of 5 all around. So you just fix it up like that. So this is x squared plus y squared equals 25. Okay? Oh, by the way, let's put our 1, 1, negative 1, negative 1. Okay? So, now we have to work with our line, right? We have 4y equals 3x. And remember, we want, let's put up in here line. We want this to be y equals mx plus b. So we got to make the left side just a y. So we'll divide both sides by 4. So what we get is y equals 3/4 x. Or 3x over 4. It's the same thing. Alright, but since we want mx plus b, I'm putting the 3/4 in front of the x, because that's our m. M, and here is our b, which is 0, right? There's nothing there. Right? So this is really a plus 0 here. So our y-intercept is right in the origin. The y-intercept is 0, right, on the y-axis. And my slope is 3 over 4, so I go up 3 and to the right 4. 1, 2, 3, 1, 2, 3, 4. I also go down 3 and to the left 4. So 1, 2, 3, 1, 2, 3, 4. And I draw my line. And this is the line 4y equals 3x. I usually put the original on here. Okay? There's 2 points of intersection, right here and right here. Now, it looks like those points cross right on that, right at this point here, alright? It looks like they cross right where those two lines meet, but that's not necessarily true. Okay? We might not be able to actually identify those points. So what we can do is we can try to check to see if that would work. So first we'll check the point. Let me put this. First we'll check the point 1, 2, 3, 4, 3. Okay? And we'll check it in the first equation. We'll check it in the circle. X squared plus y squared equals 25. 4, remember always put it in parentheses, 4 squared plus 3 squared equals 25. So we have 16 plus 9 equals 25. We have 25 equals 25. So it checked in the first equation. Okay. Now let's check it in the second equation. 4y has to equal 3x. So 4 times 3 has to equal 3 times 4, and 12 does equal 12. So the first point is valid. So we can put here in parentheses 4, comma, 3. And remember, let's put our quadrants here. I forgot about that. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. That point is in quadrant, so I'm going to put in quad, that's short for quadrant, you can do that, and that's quadrant 1. Okay? Now let's check this point, negative 4, negative 3. So let's check the point negative 4, comma, negative 3. So we have x squared plus y squared equals 25. We have negative 4 squared plus negative 3 squared equals 25. And that's 16 plus 9 equals 25, and 25 equals 25. That checks. And one more time. See how we have to check both? See how we have to check each answer in both equations, okay? So then we have 4y equals 3x. 4 times negative 3 equals 3 times negative 4. And yes, negative 12 equals negative 12. So it checked. So our other answer is negative 4, comma, negative 3, and that's in quadrant 3. 1, 2, 3. Okay? That's a Roman numeral 3, by the way, for quadrant 3. So I circled my solutions, I wrote down my solutions, I wrote the quadrant they were in, I labeled my equations, I showed my check. Let's outline this so that it looks proper. Okay, I promise you, again, if you write anything sloppy or not clear on the Regents exam, you will lose credit for that. Okay? You must write neat, otherwise you're going to get points taken off. And with the way I showed those checks without separating everything, I mean, if you want to do it a different way that makes it clear, it's fine. As long as it's clear, you can do it your own way. But with the way I had it there, it just looked like too much stuff that wasn't separated properly. So now I'm going to separate it properly. Alright, so first I have check. And then I check the point 4, 3 in both equations, and I check the point negative 4, negative 3 in both equations. And now I'm going to draw a line down in between to show that I checked it in 2 separate equations. Right? Because I did 1, 2, 3, 4 checks. So there you have it. I think it was much better doing the problem with the work on one side and the actual graph on the other side. So we're going to do the rest like that from now on. And so that is the end of problem 2. Alright, let's start with the third one. So again, I'm looking for 5.5, which is here. So I'm going to cut my paper right in half, about. Okay. And this is about 5 1/2. So again, I'm going 2 3/4, because that's half of 5 1/2. So that's where I'm going to make my y-axis, right in the middle there. Now I'm going to make my x-axis. So let's see, I got 8 1/2, so I'm going 4 1/4. So, this is number 3. Solve the following system of equations graphically. Now let's put the quadrants in here before we forget. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay? 1, 2, 3, 4. Now here's our system of equations this time. We have y equals 5 minus x squared, and we have y equals x plus 3. Okay? So, well, I know that this is my linear, my line, because nothing is squared, right? So this top one here is going to be a parabola, because I only have one variable squared. So parabola. Oh, and by the way, with these circle ones, you're not going to be graphing these on the calculator. That's why I didn't do that. For this year, it's too complicated to show you how to do that. You will probably learn how to do that next year or the year after, but it's not necessary, it's too much work, and it's too much additional stuff that you'll have to remember. So don't worry about using the graphing calculator when you have a circle problem, okay? But when you have a parabola problem, you have to use it. Alright, now, let's work with our parabola first. Now, we know for a parabola, it's y equals ax squared plus bx plus c. So we want to put this equation in this form, okay? So we have y equals first, that's good. So we have the same thing in the front at least. Now, the 5 is supposed to go at the end, right? It's the plus c part. And this 5 is positive, so I'm just going to put it underneath this c as plus 5 over here. Now we have a negative x squared, okay? And that goes where the ax squared part is. So underneath this ax squared part, I'm going to put this negative x squared. Okay. And now, I don't have any x term here, right? I don't have any term here for my plus bx. So what I put in here is plus 0 x. Okay, because my b is 0. So, my a is negative 1, right? That's what's in front of the x squared. It's negative 1. My b is 0, right? And my c is positive 5. So maybe that'll help when you plug it into the axis of symmetry formula, right? Which is what we're going to do next. Axis of symmetry is x equals negative b over 2a. So that's going to be negative 0 over 2 times negative 1. That's going to be 0 over negative 2, which is 0. So my axis of symmetry is x equals 0. Okay? So that means that my y-axis is my axis of symmetry. Okay? So, don't forget about labeling our 1, negative 1, and negative 1, so that we're showing people who look at our paper that our graph goes by ones. Okay? So, I'm going to draw an arrow coming off of my y-axis, and I'm going to call it my axis of symmetry. And it's x equals 0. Now, I would make it dashed, but it's already a solid line, so you're not going to see the dashed line, alright, unless I made it really thick, but you don't have to, alright, because it's underneath or on top of the axis, okay? So, that's my axis of symmetry. Now, we also want to do our table, right? And for our table, we have an x and a y, and then we have 3 spaces above the 0, above, right here. So we have 3 spaces above, then we have our axis of symmetry value, which was 0. And then we have 1, 2, 3 spaces below. So our table will be a total of 8 long, or 8 rows, and it will be 2 columns. Now, the last time I made a table, I made it so that my higher numbers were up here. I'm actually going to switch that around because I want it to match the calculator. And the calculator has the low numbers going, it goes from low to high in this direction, from low to high. So that's how I'm going to do it. So I'm going to go from 0, I'm going to subtract 1 to get negative 1, subtract another 1 to get negative 2, and subtract another 1 to get negative 3. And then I'm going to go the other way and go up. So I'm going to add 1 and get 1, add 1 and get 2, add 1 and get 3. So, and I'm going to put an arrow pointing at my axis of symmetry value. Okay? Oh, don't forget this line down the middle of your table to separate the x's and the y's. Now, I'm actually going to show you how to use the calculator to pull these values right out of the table to save time, right? So let me, to get out of this table here, you can hit graph and then hit clear, or not. Yes, you can. Now I'm going to go to my y equals and I'm going to clear my equations out of there. And I'm going to put this equation, this parabola, in the y1 value. So I have 5 minus x squared. All right? Now I'm going to hit second graph to go to my table. Second graph. Here's my table. So, when x is negative 3, my y value is negative 4. And when x is negative 2, my y value is 1. When x is negative 1, my y value is 4. When x is 0, my y value is 5. And now it should go 4, 1, negative 4 in the other direction. And it does. 4, 1, negative 4. Okay? So that's a quicker way to pull out your table from your calculator, which you should do. Now, let me plot those points, okay? Now I know my axis of symmetry point is going to be on my axis of symmetry, so 0, 5, I'm going to plot that one first. Okay? And now my other points will be on both, will be evenly distributed around, will be symmetrical around the y-axis, the line x equals 0. So negative 1, 4 and 1, 4. Well, here's negative 1, 4, and here's 1, 4. Then I have negative 2, 1 and 2, 1. Negative 2, 1 and 2, 1. Then I have negative 3, negative 4 and 3, negative 4. So negative 3, negative 4, and 3, negative 4. Okay? You see how it's symmetrical about that axis of symmetry, which is the line x equals 0, which is also known as the y-axis. This is the line x equals 0, the y-axis. So now I draw my parabola coming down through that point, and then it goes on and on and on and on. So I just go like that. Okay? And then the other side, now it curves around this point. That's its high point, its turning point. And it comes down. Remember, it's always curved. So don't draw any straight lines here if you can prevent it. There it goes. Okay? And you can see how it's different from my first one. My first one was going was a valley, right? This one is a hill. Okay? And the reason why this one is upside down or a hill is because that negative in front of the x squared flips this thing. Okay? It makes it go the other way. Now, I'm done graphing my parabola, except I got to put the equation on it. So I'm going to put y equals 5 minus x squared. Okay? Now I got to graph my line. Well, thankfully, it's already in the right form, y equals mx plus b. So my m is 1. And my b is 3. So I start at a y-intercept of 3, right? And I go up 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I can also go down 1 to the left 1, down 1 to the left 1, down 1 to the left 1, down to the left, down to the left, down to the left. So that's enough. Now I'm going to draw my line. Those points help me line up my line properly. And I draw it so that it almost goes to the end of the graph, right? And I'm going to label my line y equals x plus 3. Now, I need to circle the points where the line and the parabola intersect. Okay. There's 1. There's 2. And I need to write those points down, and I need to write down what quadrant they're in. The coordinates of the first point, I'll put it right here. 1, 1, 2, 3, 4. 1, comma 4 and that's in quad 1. Okay? And then my other point is at negative 2, comma 1, and that's in quad 2. Okay? And finally, what I have to do is check. So let's put that over here. Okay? I'm going to check my first point, 1 comma 4, and I'll check it in y equals 5 minus x squared. 4 equals 5 minus 1 squared. 4 equals 5 minus 1. 4 equals 4. That works. Now I'll check it in my line, which is y equals x plus 3. So 4 equals 1 plus 3. 4 equals 4, and it checks. Now I'll check my other point, which was negative 2 comma 1. Y equals 5 minus x squared. 1 equals 5 minus, in parentheses, negative 2 squared. You got to be very careful. Alright, make sure you always plug a number inside parentheses, especially when it comes to negatives. So now we have 1 equals 5 minus negative 2 inside parentheses squared is 4. Watch this difference here. This is why you always use parentheses. Okay. And another thing, if I'm in table, I can hit graph and then clear it, or I can just hit second quit to get out of the table. Now, watch what happens when I plug in a negative 2 in parentheses and I square it. I get positive 4. Watch what would happen if I didn't use the parentheses. Negative 4. Okay? That's why you always substitute in your values inside parentheses when you plug them into a formula to avoid that mistake. So 1 equals 1, and that's true. Then we also try it in y equals x plus 3. So 1 equals negative 2 plus 3. I didn't have to put in parentheses that time because there was nothing, it wasn't being squared, it wasn't being multiplied by anything, there was nothing next to it. So I can take the parentheses away. Alright? So now I have 1 equals 1, and that's it. Now let's just clean this up. Alright, I want you to just think for a second about someone who's grading your test, right? Now, imagine this. Now, these are people grading your exams, okay? These are teachers. What do you think is going to happen if a teacher comes to your exam and it's sloppy? What kind of an effect do you think that is going to have on the teacher who's grading your test? Let me tell you something, alright? We're not supposed to be biased, but we're human. And when we get an exam that's sloppy, the last thing we want to do is give extra points to that person. Alright, even though no one wants to admit it, it's just a fact of life. If you're going to write something sloppy, don't expect to get any extra points added on. Don't expect any things that are questionable on your exam to go your way. Alright, because if it's sloppy, they're going to be looking for points to take off. That's the way it is. And if it's neat, they're going to be looking for as many points as they can give you. Because no one likes grading a sloppy test. No one likes grading sloppy homework. Alright? And this is just something that you should learn as a life lesson. So anyway, there's number 3. I cleaned up my check so that it looks professional. I got my graph. Everything is labeled. I got my quadrants. Everything is circled. The equations are on the lines. I have all my work. It's clean. It's well done. It's neat. Alright? I've labeled my axis of symmetry with the equation. I've done everything that I possibly can do. And that is the end of problem number 3. So, let's move on to problem number 4 on the back. I'm going to look on this side where my line was. It was right here. So that's where I'm dividing this thing to. Okay, so number 4, solve the following system of equations. Graphically. And what we have is y equals negative x squared plus 2x plus 4. And then what we also have is y equals negative 4. Okay? Now, let's look at our equations. This one is obviously the line because nothing is squared, and this one is a parabola because only one of the variables is squared. So let's work with the parabola first. Remember, the general form for the parabola is ax squared plus bx plus c. So we want to make sure we're in the general form. And looking at this, we're ready to go. Y equals, our x squared term is first, negative x squared. Our x term is next, plus 2x. And our term without an x goes last. Okay, so we're not missing anything. Everything is there, and everything is already in order. So that means we can pick out our coefficients easily. A is negative 1. B is 2. And C is 4. Okay? Let's do our axis of symmetry. X equals negative b over 2a. So that equals negative 2 over 2 times negative 1. So that's negative 2 over negative 2. So that's 1. So our axis of symmetry is x equals 1. Right? Let's draw our table. Remember, I'm going down 8. Okay. And the middle is going to be where my axis of symmetry value goes. 1. So I subtract 1, I get 0. I subtract 1, I get negative 1. I subtract 1, I get negative 2. I add 1 to 1, I get 2. I add another 1, I get 3. I add another 1, I get 4. Let's pull it up on our calculator to get the rest of our values. Let me do it on this side so it's easy for me to write them down. Now, first of all, my equation is, let me plug that in properly, negative x squared plus 2x plus 4. See that? Now I hit zoom. Oh, I don't even need that. I just need to go to table. So I'll hit second graph to go to table. I'm going to find where my x is negative 2, my y is negative 4. Where my x is negative 1, my y is 1. Where my x is 0, my y is 4. Where my x is 1, my y is 5. Where my x is 2, my y is 4. Where my x is 3, my y is 1. And where my x is 4, my y is negative 4. You see the symmetry about this axis of symmetry here? We have 4, 4, 1, 1, negative 4, negative 4. See that? Second quit. I'm also going to go into y equals, I'll just leave that there for now. So, I have everything I need. What I'm going to do now is, and the line can't be simplified anymore, right? So, we're going to go and put together our graph over here. Now I'm going to look on the other side to see where my, I have to do it this way. Because my graph was on the other side of the page. So 5.5, so 2 3/4, so this line right here. Y-axis. And we got 8.5, so I'm going 4 1/4, so I'm going to this line. The closest line to 4 1/4, that's what I went to. And that's my x, right? Let's label our quadrants. 1, 2, 3, 4. Okay, and okay, and also let's show what we're going by. We're going by 1 in each direction, so we have to show the value we're going by in each direction. That's it. Now, let's graph our parabola. 1 over, 5 up. Let's graph our axis of symmetry first, right? It's at x equals 1, right? X equals 1. So that is a vertical line going through 1 on the x-axis. So I'm going to make this dotted. There's my axis of symmetry, and I label it. Axis of symmetry, x equals 1. So I plotted my first point, which is on the axis of symmetry. I plotted my my turning point there, and now I'm going to plot 0, 4, and 2, 4. So 0, 4, 2, 4, negative 1, 1, and 3, 1, negative 1, 1, and 3, 1. Notice how they're the same distance from the axis of symmetry, right? And then negative 2, negative 4, and 4, negative 4. Negative 2, negative 1, negative 2, negative 3, negative 4. And 1, 2, 3, 4, negative 1, 2, 3, 4. So we have a hill again, and I knew that because I had a negative x squared, and that means it's going to be a hill. Okay? And I'm going to draw in my parabola, and I'm also going to label it y equals negative x squared plus 2x plus 4. Now, the line y equals negative 4, if you go to your notes, I put a note here. Remember that an equation of a line like y equals 3 is a horizontal line, so that's like this, left to right, that goes through the value of 3, because this says y equals 3. So it goes through whatever that number is, and it's a horizontal line. And it goes through that number on the y-axis. Okay, so this will be a horizontal line somewhere here, and where it is it goes through -4 on the y-axis. So here's -1, -2, -3, -4. It's going to go like this. So I draw it in. Okay. And we're going to cross twice again, which is always nice. So we have y equals -4. Circle the points of intersection. Write them down. I'm going to write this one down first. Be careful with all these lines now. Okay, this is the origin. All right, so -1, -2, -1, -2, -3, -4. So -2, -4 in quadrant 3, and then we have 1, 2, 3, 4, 1, 2, 3, -4. Then we have 4, -4 in quadrant 4. Okay? So, what we have now to do is to check. So I'm going to come over to this side. I'm going to put the check over here. First I'm checking -2, -4. And I'm checking that in this y equals -x squared plus 2x plus 4. Y equals negative in parentheses. Now I put my -2 squared. You can see why a lot of people would make mistakes. Yeah, you can see why a lot of people make mistakes here. This is -x squared. So negative x is -2 into parentheses and then squared. Plus 2 times, again inside parentheses, -2 plus 4. So we have y equals, let's just plug this into our calculator to make sure we don't make any mistakes. Alright, we have negative, in parentheses, -2 squared plus 2, and then inside parentheses another -2 plus 4. And we get -4. Oop. We were supposed to plug that in for y, right? See here our y is -4, so we want to know, does this equal -4? And yes, we just showed that it equaled -4. Okay? Now let's check the point -2, -4 in y equals -4. Well, all we have to do is plug in a -4 for y, and we can see obviously -4 equals -4. Okay? Now let's check the point for -4. Y equals -4 squared plus 2 times 4 plus 4. Oh, I keep doing that. For the y, we're plugging in -4. Oh, I messed up again. We're supposed to write the whole equation down first, right? I'm getting sloppy here. I'm getting sloppy. All right. Y equals -x squared. Always write the original equation down first. Plus 2x plus 4. Y is -4, so -4 equals negative, inside parentheses, 4 squared plus 2, inside parentheses, 4 plus 4. So we want to know if -4 equals this right side here. Well, let's check. -4 squared plus 2 times 4 plus 4. And it does. So negative 4 equals negative 4. Check. Now we got to check it on this side. 4 comma negative 4. Our equation is y equals negative 4. Y is negative 4, so negative 4 equals negative 4. Okay, let's clean this up. Okay. We don't need that line there. This is like the title of the chart. Check. Okay. So there we showed the 4 checks. We've done everything. Alright, we've labeled our graph properly. Everything is circled and our axis of symmetry is done. It's on the graph. It's labeled. We put the points, the quadrants. We circled the answers. We put what these equations were. We put the arrow next to the axis of symmetry on the table. Alright? The only thing we have to do now is check it with the graphing calculator, which we forgot to do for the last problem. So we're going to do it for problem 3 and problem 4 right now. Okay? And you have to do this because you need this practice. Okay. I cleared everything. I'm going to go to y equals and I'm clearing everything out. It's already clear, right? So, I'm going to put in my first equation. Negative x squared plus 2x plus 4. I hit down arrow. Now I'm putting in my next equation. It's y equals negative 4. That's it. Now don't hit graph. Hit zoom z square. And you can see it looks just like my graph. Now, we already checked the table, right? Because that's how we pulled up this table right here. So we don't have to show. We don't have to check that again. I'll show you how to go to it real quick. You hit second graph to go to table, right? And now, oh, I did want to show you something here though. Remember, negative 2 comma negative 4. So that means when x is negative 2, both of my y values should be negative 4, and they are. Look. And now when x is 4, both of my y values should be negative 4. Let's go to 4. And look, again, negative 4, negative 4. See that? So that's one way to see the solution. The other way is to go back to the graph. And now let's do second trace to get to calculate. We go down to intersect. Hit enter. I'm going to choose 2 points closest to that first point of intersection on the left. So I got to bring that blinking cursor down until it's close to that intersection. I hit enter. Now it's asking me for the second curve, and my blinker is close to that intersection, so I'm just going to hit enter again. And now it says, okay, do you want me to make a guess? And I do, so I hit enter again. Negative 2 comma negative 4, that's what I got. Let's do it for the other point. Second trace to go to calculate. Intersect. Move your blinking thing over to the other intersection point. Right about there. Hit enter. Now it's right near it again, so hit enter again. And now it says, do you want me to make a guess? So you say, yeah, hit enter again. 4, negative 4. That's what I got. Okay, so that is how you use the graphing calculator to check. And also, some problems may require you to use it. So you do have to know how to do it. Now I'm going to go in and clear everything out, because I'm going back over to this side. Let's check this one out real quick. Okay. Now, y equals 5 minus x squared is my first equation, and x plus 3 is my second equation. Zoom z square. That looks just like my drawing. Okay? Go to the table, second graph to go to table. Now when x is 1, both of my y's should be 4. And they are, see? When x is negative 2, both of my y's should be 1, which they are. Right? Now hit graph, and let's go to second trace to go to calculate, go to intersect. Put your blinking dot near the first point of intersection on the left. Hit enter, enter, enter. Negative 2, 1, negative 2, 1, there it is. Now let's do second calculate, intersect. Move the blinking cursor over to the second point of intersection on the right. Hit enter, enter, enter. 1, 4. There it is, 1, 4. Okay? That's it. Let's go back in. Let's clear this. Now to get out of this also, you hit second quit, or second mode to go to quit. Okay? So that is problem 3 and problem 4.